Okay, so we're taking a look at what is this? 2013 question number 4, and let me really confirm really quick that that's the correct question. Okay, so it is. Okay, so I'm assuming you guys read the problem. I'm going to dive into the answer or the solution. So let me take a look. Okay, so A, find the values of x on the open interval 0 to 8 for which the function f has a local minimum. Okay, so they gave us a derivative graph. And just to clarify on your derivative graph, or let's let's go investigate like an actual f of x graph. If if we're talking about a local minimum, on my f of x graph, it'll look like something like this. Okay, now if I write out my slope for this minimum, I'm going to write, you'll have a negative, right, and then a negative slope, and then you have this zero slope, and then you got this positive positive slope. Okay, so on translating that into a derivative graph, right? Remember, a negative slope, you're underneath the x-axis, a zero slope, you're touching the x-axis, and a positive slope, you are above the x-axis. So on a derivative graph, it'll look like something like this. Okay, so that intersection there is my relative minimum. So if I'm trying to match this image somewhere on this graph, right, looks like I got only one location right there. That's the only location I have where it goes from negative to 0 to positive, right? And I believe that is x equals 6. Okay, so so I would put x equals 6. Okay, I'll squeeze it here for a little bit. And justify your answer. This is important. If you don't justify your answer, I don't believe you'll get any points on this part here. Now, how do we justify that? Because we could say, well, f prime, um, you could say f prime changes sign from negative to positive at x equals 6. Okay. Now, likewise, if they're talking about a maximum, well, then your f primes will change signs from positive to uh, minimum, right? I know they're not, I mean, positive to negative. I know they're not asking you for that, but if you want to take a look at the graph real quick, right there, that's your maximum. It went from positive to 0 to negative, but they didn't ask for that. Okay, so we just answered part A. Okay. Part B, determine the absolute minimum value of f on the closed interval 0 to 8. The absolute minimum value of f, we don't have the f graph. We just have a f prime graph. We just have a slope graph, right? But if I integrate my slope, right? If I'm integrating f prime, well, I'm going to get my my f graph, right? And if we're talking about absolute maximum, I'm going to highlight this. I hope you guys are thinking about, because especially when you did a closed interval, don't forget your endpoints, right? That could be where your absolute minimum or maximum occurs. They're asking for absolute minimum, but don't forget your endpoints, right? Now, back to problem A, we've only found one uh, local minimum, which is, or relative minimum, which is x equals 6. So I have basically 3 possible locations of my absolute minimum. And they are, I'm going to start with f of 0, as this is one endpoint, f of 6, which is my relative minimum we found in answer A, and also f of 8, which is my other endpoint. One of these locations is going to be my absolute minimum, and we're going to have to figure out these values. Now, we're going to have to use the derivative to figure out these values. Now, in the problem that you guys read, you notice they gave you this information here. F of 8 equals to 4. So I'm going to have to use that in all of these cases to figure out what those function values are, except for maybe the last one, f of 8. I already have that. Great. I already have f of 8 equals to 4. That's done. But I got to figure out f of 0 and f of 6. And I have to somehow use f of 8. Okay? So just for an example for f of 0, the way I like to think about this is I know I can do integration from 0 to 8 of, let's do of f prime of x dx. That's going to give me the actual function f at 8 minus f of 0. And that's kind of nice because I need this value here. So I could do a little bit algebra, and I could add this to both sides, and then subtract this from both sides, and I'm going to get something like this. F of 0 is going to equal f of 8 minus, oh wait, oh yeah, that's right, f prime x dx, is that right? Okay, so we can do something like that to figure out this, right? Now, f of 8, we have that already. It's 4. It's given to us. Minus, okay, so this would be the areas that they gave us, right? From 0 to 8. Now, be careful because, okay, there's a slight interruption, but you guys probably don't even notice, which is fine. Okay, so continue on here. We're doing from 0 to 8. Now I'm going to keep this all in parentheses here. And I'm going to add up all these area, remembering this is going to be a negative 3. So I have a positive 2, positive 6, negative 3, and a positive 7. Right? So once again, I have a positive 2, a 6, a negative 3, and a positive 7. That's going to give me 4 minus, that's, what is that, 8, 15 minus 12. So I'm going to get a value of negative 8. So f of 0 is going to be negative 8. And I'm going to repeat that process for f of 6. Now, I'm going to start with here, going from 6 to 8, all right, of f prime of x dx will give me f of 8 minus f of 6. And following the same process up here, I'm going to leave that to you guys to figure out, but you're going to have an area from 6 to 8 would be 7. So eventually you'll get to a point where it's 4 minus 7. You're going to get a value of negative 3. So if we're looking for the absolute minimum, well, it's this guy over here, right? Negative 8 would be my absolute minimum. And they're not looking for where it is. They want to know what is it. So we're not looking for it occurs at what at 0. No, they're looking for the actual value. So the minimum is going to be negative 8. Okay. Part C, or letter C. On what open intervals contain integer 8? It's a graph of both f both concave down and decreasing. Okay, so if it's concave down, let's see here. Concave down would mean my slope has to be decreasing. Right, so this right here is a decreasing slope. Okay, now it doesn't matter if it's positive or negative slope. It's just got to show that it's got to be decreasing. Now, if they're asking for a concave down and increasing, that means my slope has to be positive. So on a slope graph, f prime, first of all, it has to be above my x-axis, indicating I have a positive slope. But the slope has to be decreasing. So I have to look for something that looks like this. Oh, I guess I don't really need arrows. Let's do it again. So I have to look for on the graph that looks something like this, okay? So I have it is decreasing, but it is above the x-axis, which means everything here is a positive, represents a positive slope, but it's decreasing. So on the graph, it looks like I'm looking at this right here, from 0 to 1, and from 3 to 4. Those are the only locations where it has decreasing, but still above the x-axis. So I would write on what open intervals. So my open intervals would be from 0 to 1 and from 3 to 4. And again, I'm going to highlight this keyword, explain your reasoning. All right, you're not going to get full credit if you don't have some kind of explanation. So the explanation here is I would say f prime is decreasing, right? It's going down, but positive above the x-axis um, in these intervals. That would be my explanation, intervals. Okay? And part D, the function g is defined by quantity f of x, quantity q, if f of 3 is negative 5 half. Find the slope of the line tangent to the graph of g at x equals 3. Okay, so we're not looking for the equation of the tangent. All they want is just the slope of the line tangent to the graph at x equals 3. So the first thing we need to do is we need a g prime. So g prime of x is going to be, okay, so this is a chain rule, so 3 times f of x, 3 minus 1, which is 2, times derivative of the inside, so f prime of x. And so that's my derivative of my g graph, but they want the actual slope at a certain point, at x equals 3. So we want g prime of 3. So we got 3 of f of 3 squared times f prime of 3, right? Okay, so it looks like I have 3 times, and they gave us f of 3, right? F of 3 is what? Negative 5 over 2, so negative 5 over 2 quantity squared times f prime of 3. That's the slope of f at 3. Well, I'm going to go to my slope graph and identify at 3, my slope value is 4, right? So this will be just multiplied by a 4 there. And if you simplify that, you should get a value of 75. So that's my answer for part D. Okay, and that's it for now, guys.